In today's video, we're going to perform an FMEA of an electric powertrain using SLIKWORKS. We're going to take a simple look at the architecture of the electric powertrain, identify its components, and then use SLIKWORKS to perform an FMEA. This is the user interface of SLIKWORKS. It consists of a project dashboard where there is a list of projects. I'm going to add a new project for our electric powertrain. Once I click this project, then the project dashboard opens up and it lets me do a bunch of analysis. For now, you can see the FMEA and FMEDA highlighted. We're going to start with the FMEA. I'm going to click the FMEA, and there's several templates that one can use. I'm going to use the standard VDA AI template. The next thing it asks for is to upload an architecture diagram. I'm going to upload an architecture diagram for the system for which we want to perform an FMEA. Let me choose the diagram, and while I choose the diagram, I can briefly give an overview of what the system looks like. So if I open the architecture diagram here, essentially it's an electric vehicle which consists of two electric motors, one on the front axle and one on the rear axle. The front electric motor on the front axle is controlled by an electric motor unit, front electric motor unit, and on the rear it's controlled by a rear electric motor unit. Now, the torque commands to this is coming from a powertrain control unit. Sometimes it's called a vehicle control unit, or if you have a domain controller, zonal controller, it could be something different. But let's, for simplicity's sake, call it a powertrain control unit. And this in turn is getting its inputs from these two accelerator pedal sensors. There's a brake control unit which is sending vehicle speed. There's also the motor speed which is coming from the two electric motors. And all these speeds are used to estimate the vehicle speed based on the accelerator pedal and the vehicle speed. You estimate the wheel torque. The wheel torque is then limited based on the system power limits. And then there is a torque split between the front and the rear uh, to then determine how the driver torque request is implemented by the front and the rear motors together. This, in a nutshell, is what the uh, system we have. Um, it's popular in a lot of electric vehicles. Our goal is to now perform an FMEA on the system to identify safety mechanisms to see if the safety measures that we have in the technical safety concept are good enough. Now, going back to SLIKWORKS, we're going to use the AI functionality to extract components. With the image analysis algorithm within SLIKWORKS, what it does is it scans through the entire architecture, which is all of this, and it tries to identify every element, all the IO for each element. So as an example, we can just take three elements here. So let's take the accelerator pedal sensor one. Let's take the accelerator pedal sensing, and then we can consider the front electric motor control unit, and we'll see how it's identified the elements. So we had the accelerator pedal sensor one. Um, oh, sorry, accelerator pedal sensor one. It has, you can see zero input, output, zero inputs and one output. There's no input, and the output is accelerator pedal sensor one, which is what this is. Then we talk about accelerator pedal sensing. We can look at accelerator pedal sensing. If you There's two inputs, pedal sensor 1, pedal sensor 2, and the output is accelerator pedal value. Pedal sensor 1, pedal sensor 2, and then there is a pedal value. Now, if we talk about front electric motor control unit, we can take a look at the front electric motor control unit. It has two inputs. One is the motor torque request and the motor torque enable. Deliberately, I've not named this because it's just the physical connection to the electric motor. So for now, we can just consider that the torque from an EE standpoint, it is the torque request. After this, it's completely an electrical component which is converting the torque into voltages and currents. So with this, we can also say, for simplicity, we can eliminate this electric motor. We can say the electric motor is not part of the scope. Now that this is available, we go to the next step, which is we have to identify a list of effects and a list of safety measures. Um, Now we've performed a HARA already, and we have a list of hazards that we can upload. So I'm going to click on upload image, and I'm going to upload hazards. It's uploaded these hazards. For now, everything is based on image updates. We're working on a feature that allows users to upload, let's say, hazards from requirements management databases as well. Now, similarly, we're going to upload a list of safety measures which we've identified in in the technical safety concept. As you can see, this is not this four safety mechanisms. It's not a complete set, and the whole idea of an FMEA is to identify what the complete set is. So we've just identified as a starting step four safety mechanisms: pedal monitor, communication end-to-end protection, torque monitor, torque split monitor. Now that this is available, we go to the form sheet and we are going to generate a form sheet. Before we generate the form sheet, there's one thing that needs to be done. Um we need to identify what are the component types, because that's going to define how the form sheet is being generated. And we are going to focus on three components, which is uh, pedal sensor 1. So you can see over here, pedal sensor 1 is a scalar sensor. If we've set this right, then the failure modes predicted in the form sheet will also be correct. Then let's go to accelerator pedal sensing, which is a function. So because it's a function, what we need to do is we need to set some, um, we need to perform a hazard. So here we say more, and then we say less, and we say changes. Well, what is going to happen at the form sheet is we're going to the tool is going to combine these keywords along with this and then identify the failure mode. Then we're also going to consider front motor control units, processing unit. Here you can see that it's identified two signals as an input. This will show up as a failure mode, as a cause for a failure mode once we go into the form sheet. So now we go to the form sheet and we click on generate form sheet with AI.